So today we're going to do secants. We're going to be gluing in something in half of our notes here. So when you write this definition, try to only use like half of your lines here. Does that make sense? Because we're going to glue something in on this half, but we just won't glue it in quite yet. So try to write this definition, stick on this half of the paper. A secant is a line that intersects a circle How many times does it intersect a circle? No picture. A tangent intersected a circle how many times? 1. So a secant is going to intersect it twice. Alright, DC. Too much. Yeah, you just said how tired you are, and yet you can't stop talking. You can't stop doing things. You're so tired, but I'm going to just keep talking. Alright, here I have a circle. So a secant, it doesn't matter where it goes through the circle, but it's going to go through the circle, so that way it goes through it 2 times. If it enters the circle somewhere, it's going to have to go through the circle in a different direction. And it's going to hit that circle 2 times. Once on the way as it goes into that circle, and once as it goes out of the circle. Okay, remember yesterday we talked about a tangent, and a tangent intersects a circle how many times? Twice. Alright, Miss Stoner is going to be passing out the foldable that we'll be working with today. Once. I don't know, I thought you said twice and I just repeated what, yeah, you said once. Tangent, let me say it again then. Are you ready to hear me say it, be so smart? A tangent is a line that intersects a circle once. Did I do it right that time? Got it. Nailed it. Alright, for your foldable today, you're going to look at it with the words up. Because it's just a lot of different things. Yeah, because we're going to fold it.
We're going to stick it in here and then fold it?
We're going to fold it. I like to fold it and write on it and then stick it in at the end. That's because then it's just easier. Okay, so words are up. Have your words face up. You're going to fold it in half so that the words are on the inside of your foldable.
Is it even? Like the paper is even?
Should be. What do you mean? I don't know.
Yeah, just right down the middle. It should be even.
Okay, so you folded it so that the words are in the middle. Here are the words. Fold it so the words are in the middle. Alright. Now listen very carefully because I didn't make that many extra copies. And my extra copies I did make, period 4, screwed up a lot and took my extra copies. I didn't explain it very well. When you cut it, you are only going to cut this top flap. So you're going to cut in between these parts here that have the words.
So when you're done, it's going to open up like a little book. You're not actually cutting these apart. You're making little windows. Okay?
So you're cutting it so that the bottom stays all as one. You guys know how you're cutting it?
So you're cutting apart the one that has the picture and the words. Because the blank part is the part that will be glued down into your notebook.
You guys know how you're cutting it?
Can I glue this in?
Yes, I can mine in. This Meryl likes to wait because she can move it around. So if you want to wait. If you want to glue it, glue. I have to glue it so I can figure out what yep.
Hold it to your words on the inside.
Yep, so right there.
Alright, I like to wait to glue it in until the end because sometimes it's a little difficult to write on the flaps if you glue it in right away. So I always glue it in at the end. If you're impatient and you're like really want it to be glued in, you can glue it in, but It's going to go in right next to that definition. If you want to glue it in right away, you can. It's going to be glued in right here next to the definition so that it fits on the page. But I like to write on mine before I glue it in. I glue mine in at the end. Alright, at this point, if you have not taken out your 3 colored pencils, I would take those out. I'm using orange, purple, and green. Alright, here we go. I'm using 3 colored pencils. Alright, we're going to be color coding these as we go. The reason why it's a foldable is because when you look at all of this, it can just be a lot. Because we're going to write in some equations here, some formulas. And it can be too much. The reason it's a foldable is when you get to a problem, you're going to identify which problem does it look like, which figure. And then you'll open up just that flap so it's not like your brain is overpowered by everything. Cool beans? Okay. Some people were like, why didn't you just make this a table? And I was like, hey, next year. Cool. All right. First one, we have 2 secants intersect. So 2 secants. I'm going to do all my secants today in green. Okay, so when I do secants, I'm going to use green. So secant are the lines that go through the circle. So I have this green line here that goes through the circle. And this green line here. So the first thing that's really important today is the secants and tangents. No, I think you did it great. I think you cut it from the wrong edge. Wrong way. Alright. And they're going to intersect inside the circle. So I'm going to use orange anytime I'm showing where it intersects today. Inside. So I'm going to just make a point where those 2 lines cross with my orange. Alright, so for our formula, in this one, if I look at angle 1 is colored in red. How many arcs are colored in red also? 2. Because we know angle 1 is the same as the angle across from it, vertical angles, right? So we're going to use both the arcs, one across from this one and from the other side when we do this. So we're going to write measure of angle 1, and you might need to write kind of small for this, equals, and we're going to do a half times the quantity of, meaning we have parentheses. We're going to do this part in parentheses first before you multiply by a half. What's one of the arcs across from angle 1? AB. So the measure of arc AB and we're going to add it with the arc across from that vertical angle because we know these 2 are the same angles, so we're going to look across at the other arc. So what is the other arc there? CD. So because we have vertical angles there, we're looking at two different arcs, the arc across from each angle, and those angles are congruent. If I was looking at angle 2, which arcs would I look at? What's across from 2? BC. And what? AD. Yep. So you're just kind of looking at what's right across from it, and then what's across from that vertical angle. Alright, that's that first one. I'll leave it up there in case you need it. Alright, our second one. When we look at the picture of the second one, which line is the secant line? Which line touches the circle twice? The line going across the bottom or the line going through? Through. So this is our secant. What's this line going across? A tangent. Because how many times does it touch? Once. Alright, so a secant, I'm going to use green again, because I'm going to use green for all my secants. And my secant is that one that goes through the circle. You're going to go to the bathroom and pray?
Yeah.
But this time we also have a tangent. I'm going to do tangents in purple today. So a secant and a tangent intersect. So tangent, I'm going to use purple. You can use a different color. That's fine. It doesn't have to be the same colors. Okay, and this time they intersect at the point of tangency. Who remembers from yesterday, what is the point of tangency? Or what point is the point of tangency here? Point of tangency, we're going to look at the tangent line. And point of tangency is where the tangent line touches the circle, that one spot. So where does our tangent line touch the circle? A. And that's where the two intersect, is they intersect at that point of tangency. Alright, this time we're going to do angle 2, just for funsies. Did any of you watch Sesame Street growing up? You know, like how Sesame Street, like the episodes were always brought to you by like the letter T and the number 4. Today's lesson is brought to you by the number 1/2. We're going to use it every time. Just gets repetitive. I don't know. Alright, what is the arc across from angle 2 this time? Across from angle 2, I'm looking at this blue arc. What is the name of that blue arc? BC, I want to go to B and end at C. I want BA, I want to start at B, end at A. But if I say BA, am I talking about the blue one or the red one? The red one. So how can I make sure I'm starting at B, ending at A, but going towards the blue? BCA. Crushed it. Good brainstorming session there, guys. BCA. Because what type of arc is BCA? A major arc. It's the longer way around, so we need those 3 letters. And all we do is half of that. It's similar to that inscribed angle. It's like we're creating an inscribed angle, but we're using the whole arc. It doesn't just cut the arc off. Same thing with angle 1, but what arc would we use for angle 1? The red one, AB. Alright, up next. This time, if you look at those 2 lines there, I have ABD, that's one line, and ACE, that's the other line. AD, is that a secant or a tangent? Why? Touches it twice. What about AE? Also secant. So in this one we have 2 secants. But we already did a problem with 2 secants. That was the top one. So why is this one different? Between these two, what's different? What? They do intersect, but where? This one, they intersect on the inside, the top one. This one, they intersect on the outside. That point A where they come together is on the outside of the circle. So it makes these pictures look a little bit different. So our only angle here that we're looking at is angle A. So we're going to do the measure of angle A equals, guess what number we're going to use? 1/2. Nuts. Times. Now this time if you look between those green lines, how many arcs are there between the green lines? We have the BC arc, right? And we have DE that are kind of between those two. They're trapped in between the green, the top and bottom. So we have BC and DE. So because we have 2 arcs that we're looking at, we're going to use both. But we're going to use subtraction. So we want the bigger arc minus the smaller arc. Which arc is going to be bigger, the one closer to it or the one farther away? The one farther away is usually bigger, is always bigger. So we're going to do the measure of DE, the arc, minus the measure of BC. So we're going to subtract those 2 numbers, then multiply by 1/2. And that would give us that angle A. Because there's 2 arcs here. All right, on our next picture, is it 2 secants, 2 tangents, or a secant and a tangent? What is AD? A secant. What about AC? A tangent. So we have a secant and a tangent. So this time we have a secant. That's that line AB or AD or BD, whatever you want to call that line. And we have a tangent. We had that earlier, 2 up. We had this one where we had a secant and a tangent. Where did these ones intersect? They intersected at point A, right? It was like on the outside of the circle. But it was right on the circle. Not on the outside of the circle, it was right on top of the circle. This time, where do they intersect? C would be the point of tangency. Do the purple and green intersect at C? Nope, they intersect at A. So they intersect outside of the circle. So it's not at that point of tangency this time. So that's what makes this one different than the other one. But it's really similar to one that came right before this. We're going to think the measure of angle A equals 1/2. And with these, again, between that green and purple, how many arcs are there really? 2. We have B, C, and what? BD would be a segment. I want the arc, like on the circle. So we have BC, and then the other part of the circle, CD. Yep. So we're going to subtract again. We're going to start with the bigger one. So the bigger one is the one further away. So CD, or you could call it DC, either way. Minus the measure of BC, the one closer. All right, one more, and then we are done with our notes. All right, on this last one, what are the lines we are given? Are we given 2 secants, 2 tangents, or a secant and a tangent? 2 tangents. And we know with 2 tangents, which parts are congruent? Just remember from yesterday? What segments will end up being the same here? AC will be the same as what? AB. If you want to mark that just for funsies, you can. It doesn't really have to do with today's lesson, but if this looks familiar to you and you're like, oh, we did this yesterday. Yep, we did. We said that these were congruent yesterday. Today we're worried about angle measures, though. Okay, so here we have 2 tangents. So I'm going to use purple for my tangents. So they both touch the circle exactly 1 time. But those purple lines, they intersect each other outside of the circle. So where they come from? They come from point A, that's on the outside of the circle. So we know that the measure of angle A equals... No, not this time. I'm just kidding. 1/2 times, and then it's the same idea. We have 2 different arcs here. We're going to subtract again. So which arc are we going to start with? The blue one or the red one? The red one. The red one, is that a major or a minor arc? Major. So how many points do we need for major arcs? 3. So how would I name that red arc? C... DB, yep, or BDC. Minus, going a little crooked here, that's okay. What's the blue arc? BC, yep. We have one little hint here that's going to help us on these problems. When you look at that blue arc and the red arc, together they make the whole circle, right? Is there any part of the circle that's not in one of those arcs? No. So that's going to be our hint here, is that we know that those arcs are going to add up to 360. So the measure of CDB plus the measure of BC will equal 360. Sometimes they'll only give you one arc measure because you could just subtract it from 360 to find the other arc. Okay, so usually on this picture they won't give you both arcs because you could just subtract from 360 to find it. Okay? Alright, you can glue this in. I set mine up so I could glue it in right here because I have my definition here, and then I'm going to glue it on the side. Okay, if you didn't glue it in, you can glue it in. All your practice today, it's going to look like one of these pictures, and you're going to be asked to find the angle. So you just have to decide which arcs are you going to be using to help you find those angles. 6 problems, shouldn't take you too long. I'd glue this in, and then you have the rest of the time to work.
One quick thing about your practice work today.